Hello, hello student. Today we are going to start our next topic from the class 10th physics. Over there, we will study current, electricity. Over here we need to understand what actually current means. What is current? I is current and that is equal to Q by T. The unit of current is ampere and the charge over here is coulomb and time is second. Here we can define 1 ampere is that current where 1 coulomb of charge passes through a cross section of wire in 1 second. Over here we need to understand that what is actually Q. Q is basically the amount of charge, Then we have N is number of electron, E is charge on electron, that is 1.6 into 10 to the power minus 19 coulomb. Over here, so suppose we need to find how many electrons will required to form 1 coulomb of charge. So we see that 1 coulomb is equal to N into E. N is equal to 1 by E. E is what? 1.6 into 10 to the power minus 19. This is coming out to be 6.25 into 10 to the power 18. This much electron is required to make 1 coulomb of charge. Now we'll move on to the next topic, that is what is electrostatic potential. Electrostatic potential. What is potential? We calculate it out. See, potential basically means it is an amount of work done in moving unit positive charge from infinity to that point. Potential basically is equal to work done is equal to charge into potential. Potential is basically work done upon Q. Unit of potential is volt. Unit of work is joule. Then we have unit of charge is coulomb. We say that potential difference between 2 points is equivalent to 1 volt if 1 joule of work is done in moving 1 coulomb of charge through it. Potential difference between 2 points is said to be 1 volt if 1 joule of work is done in moving 1 coulomb of charge through it. Then we now we go for the next topic, that is Coulomb's law. Over here, next topic is Ohm's law. What is Ohm's law? It states that, see over here Ohm's law, current passing through the wire is equivalent to potential applied and V is equivalent to I. V upon I is equivalent to R. That is constant. Ohm's law states that current passing through a cross section of wire is directly proportional to applied potential. And what we need to keep constant? We have to keep constant the temperature and mechanical strain. Now we'll follow what are the factor on which resistance depends. So we say that resistance is directly proportional to the length of the wire and inversely proportional to the area of cross section. Then we have resistance is equal to rho L by A. Rho is what? It is called coefficient of resistivity. Coefficient of resistivity. See, ohmic substance will have, these are those substances which follows Ohm's law. It will have VI diagram like this. V and I diagram is like this. Means current passing through the wire is directly proportional to the applied potential. Now we'll move on to the next topic, that is what is the total resistance in series. Let us suppose we have three resistors which are in series. We have R1, this is R2, this is R3. Potential applied is V. In series, we'll have potential over here will be V1, V2, V3. They will have same amount of current. In series, we have constant current flowing through it. Potential is divided like this: V1 plus V2 plus V3. We have I into Rs, this is I into R1 plus I into R2 plus I into R3. The resistance in series will be equal to R1 plus R2 plus R3. These are resistance in series. Now we'll move to how do we calculate when the resistors are in parallel. See, we have, this is applied potential over here. We'll have different current will get distributed. In parallel connection, we'll have different current, but potential across this junction A and B will be same. So what we see that current is getting distributed over here, I1 plus I2 plus I3. We have current is what? V upon R in parallel. This is V upon R1, V upon R2 plus V upon R3. The potential across all these are same. So in parallel, what we will have? Total resistance will be equivalent to the sum of reciprocal of indivisible resistance. Now we will move on to the next topic, that is power. See, power is basically rate of doing work upon time. The unit of power is basically watt. That is joule, this is second. We say that power of an engine is said to be 1 watt if it does 1 joule of work in 1 second. And there is larger power of unit, 1 kilowatt hour or megawatt. We know this, that is 10 to the 3 watt, 10 then we have megawatt, it is equivalent to 10 to the power 6 watt. See, normally what we have, power formula which we utilize over here is power is equal to V into I, or we have I square R, or we have V square by R. Over here we have one important unit, that is commercial unit of power. Commercial